plantation waste. So I'll send this one around this way. I mean, literally, this is our raw material. It's the stuff they burn there, okay? This is that. That's a process that we developed.
With all sorts of toxic glues, right? You greenwashing corporate charlatan.
Thank you. There are no toxic glues. There's no, this is coconut husk, period, and I'll give you a little asterisk to that in a second. There's nothing in there but heat and pressure in that. There is no glues, there's no formaldehydes, there's no other binder other than the coconut itself. And I don't think I need to pass around coconut fronds because you guys know what that is, but I'll just send around this little piece as well. So you can see this was engraved there also, but that's pretty much a very similar one. But here is another thing, again, where life sometimes surprises you with things. What we realized, again, recognizing that we had this huge problem of plastics in the Philippines that was a waste, we said, what do you think? This is my colleague Robert, if he was here, he would tell the story much better than I can. But what if we took a percentage of plastics, the kind that everybody hates, the unsorted, the ones that are dirty, they have a label, a little bit of food in them, the ones that nobody else can use, right? The number 7 plastics that everybody wants to say we have nothing to do with them. Well, what if we, our company, took those waste plastics and we found a way to actually put them into the board. So what this is, our process that we have here, again, nothing but coconut, and all of that garbage plastic is now embedded in this board. We can embed 40% of plastic waste that nobody else wants into a board that will now last 100 years and is recyclable. So I'm going to pass this one around as well. You can look at the plastic that's in there. There's nothing else in there. Now the beauty of this, if you haven't already guessed it, is we can take all of that plastic that's in the Philippines, 100% of that plastic that's going into the ocean, and we can sequester it there so that it never goes into another ocean again. And that's also part of what we have here. By the way, you could eat that if you wanted to.
Oh yeah?
Yes.
Like a brownie?
Yes, like a brownie.
I thought about it.
When we make it, it actually smells like a bakery because it's actually, yeah, so you got a little bit of a coconut and the sugars in there and everything else, so. But that piece of wood there is, the reason why we made it as small as we did, or as thin as we did, is that is a sign when you've actually perfected your process. Because if you normally make wood that thin, it warps anytime you get like change in humidity or anything else. And so the fact that we have that piece there is probably 2 years old. It's been in every kind of humidity, every kind of change, and that wood just stays exactly the same as it is. And again, it's one of those things where we can either make that or we can make that really hard board there for making the building materials that we have. And so, so that's the last of it. So TH, I think that's it, unless you have any other things that you think I missed on the,
No, I just want to get the jaws dropping. Yeah, good. And tongues out and the salivating and like when do we get started and how can we do it?
When
And
you collect the plastic, like
Yes.
the photo that you showed of the river with all the plastic on top,
yes.
would you just like scoop up that plastic, right? And it can be dirty with the labels, the number 7s, everything that no one wants.
It doesn't, it absolutely positively does not matter. So what we do is we have a community collection sites that basically we're working now with schools. We're trying to implement a school program that basically the schools will bring in all their plastics from home. So each week they'll bring them in and they'll collect them at a central place in their school. And then the school that collects the most plastics will actually have a grinder. We'll actually grind them all on site for the school, show them actually where it is, and then we'll actually give them some sort of a prize. Well, usually it's a meal that we'll do for them because again, most of these schools, need it. Or we'll host a party for them and we give them a lot of things, or buy books for them. We bought a lot of books for the schools down there. So we'll do something that enables them to be part of the solution again, right? What are we doing? We're not going around and getting garbage trucks to go around. We're having the kids bring it in. And again, what does that also do is it helps them to internalize the aspect of what is the impact of the plastic that I have.
Yeah.
So one of the things the reason why I asked all of you guys, and I love the fact that every one of you has a slightly different twist on it, but I'm hoping that every one of you could see on what you said that you were interested in doing, that there's some piece of that in this project here, where there's community engagement of how you can do that and what can happen. We're helping food security because we're taking all that stuff and is literally creating food forests out of, these things of dying coconut plantations. So what I want you to think about in the way that you perceive this is, and just making sure that, it's not always what you see, the first thing. Sometimes you can turn something around and you can find that there's a whole nother way of opening it up and really getting the value out of it so that it can work. And one of the things that we've worked very, very hard on is to try to find the levers that we can pull and manipulate within our project that would enable it to have all of those positive attributes. Because it's not obvious when you first start, when you first go down there, you say, well, can we make boards out of coconut? Well, yes, we could do that, and we could make money at that, right? We could literally just go and collect all that. But part of the whole system, to make the whole system work, involves replacing the defective coconut trees with hybrids and creating a food forest. And guess what that does? That increases the carbon dioxide uptake. It helps create food security. It helps alleviate poverty. So now all of a sudden you have this, and you're creating all of these stabilizing effects within your project. So again, it's not like a case where, again, I can tell you there's not a lot of people competing with our value proposition. And again, once we start putting this out in the market, I know that there's gonna be a bunch of, companies that'll come there and say, well, we can make coconut wood cheaper. But you know what, the community is really not interested in making coconut wood cheaper. They're interested in actually all of those other things, because it's the community that's interested in improving the outcomes, their health outcomes, improving their food resources, improving their livelihood. So it's not just about somebody making cheap coconut wood. So again, you have to think differently. And I know I'm borrowing some Steve Jobs words there, but with my one more thing and my think differently. But it really is that when you get to something that you feel like has those capabilities and those attributes, they're just not things that you normally see in the way people run businesses today. Again, think what you want about Elon Musk. He's certainly a character of our times. But he literally changed the whole EV world, right? I mean, we wouldn't have had electric vehicles without Elon Musk, right? That's one guy. I mean, granted, I'm not a billionaire, so I can't write the same checks he does. So it forced us to be more creative and figure out how can we build a system that funds itself. Once we build it, every one of these factories that we build has enough free cash flow to build 2 more. And then those 2 can build 2 more off of that. And while we're doing that, we're replacing trees, we're creating food forests, we're doing all these other things. But again, at some point, we'll put out some green bond offering, and we'll do a $5 billion green bond offering so we can put 1,000 of them up at a time, because that gets us further down the road. We don't have to wait for 50 years for us to do this, logarithmic, right, can't speak now, logarithmic, saying. Growth rate of, 2 times 2 times 2 times 2 and so on. It would take a while to do that, whereas we'll do a green bond offering at some point and just go float 1,000 of them. 1,000 times, 10 million is 10 billion. So, that's a big green bond offering at some point. But our goal is to be able to demonstrate that we're doing this and show the people that our theory of change works, and our scorecards are producing what we say they will, and then we'll be able to run that green bond very easily, because there's no climate project anywhere on Earth that has the kind of metrics that we have there. So, with that, I'm going to open it up to questions. I hope you have a few. But I'd be delighted to do it, and I appreciate your time and listening. You've been great in just listening, so thank you very much. Thank you.
Let me show the video.
You want to show it real quick?
Yeah,
Can you?
I can do that. If you just hold on
Yeah,
to this.
you can- So I'll take some questions when you're
Yeah.
queuing it up there.
Oh, I was just curious if the trunks are of a similar material, like if you do get those big storms, can those also be incorporated?
Yeah, we have a whole plan for that, actually. We have a quick response team, again, which they're not doing right now, but when those coconut trees fall, there's only a certain amount of time, it's a very limited amount of time before the tree starts rotting.
Yeah.
So basically what we have is we have these portable sawmills that actually we can deploy to a typhoon area, and then we can actually put a whole kiln-based, fire-based system to be able to get, very high-quality lumber out of those trees. So it's a different way of making the lumber. In that case, it looks much more like harvested timber, as opposed to ours, which we take the biomass, we grind it up into fibers, and then we reassemble it as an engineered wood through our process. So the 2 products would be very different, but yeah, that would be something that would be is part of our program there.
Cool.
Yes.
So this is one of many questions, but, because, I know Austin and I were in the class last semester when you came in, and it was right before you guys had left to go to the Philippines, and you were mentioning that you were meeting with, I believe they term it president as well.
Yes.
And I was just curious how all of that went, because I know there was some hesitancy in when you were really kind of describing potentially what could happen.
Yeah, so, again, one of the really cool things about working in a country like the Philippines is that you have access to people that you don't otherwise have access to. So, granted, we've been there for a long time, and we have a lot of amazing connections with people. But, yeah, so we were invited to the palace, and we went there, and we were supposed to meet President Marcos, and, but he, it was like literally 2 days before I left to come back here to the States, and then he got called out to some emergency that was happening somewhere in the region. There's always emergencies happening there. So we ended up meeting with the First Lady, and she was absolutely over the moon. So she basically gave us the open door to the Philippine government, basically whatever we need to be able to put the project into place there, because they want to make sure that the Philippines is the starting point for the project. And so, and I think we'll have some information on that later. Again, as I said, we've been really bad about publicizing anything that we've done. But Lisa Marcos was a big fan of what we do and has opened up, like basically set us before all the cabinet secretaries. So imagine I can't meet anybody in our government. I have nobody on any party, it doesn't matter. Nobody will talk to us for whatever reason. I don't know why. We just don't have those connections here. But we got put in front of like the head of their Department of Energy, the head of their Climate Change Commission, the head of their Health and Human Services. I mean, just the cabinet secretaries for the Philippine government, and everyone said, what can I do to make the project successful here? Including, they said if we needed to, could they pass an executive order saying that the country would need to source sustainable lumber from a project like ours before they actually import timber-based resources. And we said, you really don't need to do that, thank you, but we don't need it because we're already less expensive and we're a better product, and we already don't have enough product anyway, so you don't need to create any more. But it went phenomenally well, and people were very supportive. We took a tour, we went through the entire country, almost the entire country, and went to all the local government units, and literally open door from all of them as well. So very high support there. And again, we're also getting inquiries from the other coconut producing countries. It's interesting because you could take the top three, I think it was the top 3 coconut producing countries in the world, and you would have 80% of all the coconuts harvested in the world, the Philippines being number 2 right now. So if you take those 3 countries, we could get 80% of it, and we could get to 10 gigatons a year, or 5 gigatons of the 10 gigatons that are needed on there. You can hold the questions, or you want to just run the video real quick?
And I do want to emphasize that when we started talking about this, we were looking at, as I remember where I came into the equation, we were looking at ways of getting the message out. And I've shown Matthew and Robert the Egunia Felicia Muskogee Eco Village graphic depiction that they had done it in Unreal Engine. We began to talk, and Matthew said, I've been experimenting with Unreal Engine. I said, I have a little, but I have more expertise in Blender and Unity, and so we started at Rosebud to sit down and try to mock up the factory that night in Blender and Unity, and found that Unity, we had Amy, your fellow student Amy, was working with you guys, and we found that the new sharing method that Unity uses called Plastic SCM was not going to work for us. It was really buggy. We couldn't share files efficiently. So they turned and found a professional group in the Philippines.
No, it was actually in Singapore.
In Singapore, who use Unreal Engine, and we're able to do it at good cost, very rapidly, and prototype this. But there's still this need for you all to be in that space of being able to use these tools. So this is not real, just one more thing, it's unreal.
Yeah, and then I'll talk to you a little bit about that. That makes me know I want to talk about this. And this is just music, so I'm gonna annotate some of this a little bit here. So again, this is still what we're talking about, is taking the coconut, but again, the coconut plantations and converting them into this carbon dioxide removal system. I mentioned that to you now, but again, remember, it's the holistic thing. People are interested in carbon dioxide and climate solutions, but the reality is it's a holistic program for poverty alleviation and food security and public housing and all of those different things. So you can see here, there's just the 3 tiers that we're talking about on there. You've got this, one of the things that we have here is, the problem with coconut plantations worldwide is most of them are spread with no farm to market roads. So coconuts are big and heavy, and so the problem is the coconut is only good as far as you can carry it. And so the guy who lives 50 kilometers away doesn't have the same market as the guy who's, 1 kilometer away and he carries his coconut. So that guy way back there has no market at all. And so they're left to produce very low value products that have no value, and that's why they end up burning all of the, 90% of the product is burnt and all the waste materials. But we have a system here where we have actually like a zip line system. They do this in banana plantations, and that's why bananas are so absurdly cheap. I'm still amazed at how cheap bananas are. I can't even ship stuff across the globe for the price that we buy bananas in Publix or Whole Foods for. I mean, they're just, it blows my mind how cheap it is. But if you look at all the banana plantations, they're all done in this manner. They're massive plantations and they're all zip lined on a system like this. We're the only one that actually uses a zip line system on coconuts anywhere in the globe. So one of the things that's unique here too is we're taking the whole coconut. Nobody processes the whole coconut in coconut world. They basically, the first thing they do is they take the coconut husk off. That's 30% of the carry weight. And then they just take the, the fuzzy brown part, which has the meat and the water in it. But in our case, we take the whole thing. And again, this is all autonomous. There's no people involved here, and there's a whole reason for that. Again, the big thing is that these are high precision machines. There's a lot of technology going on inside here. So it's not like we're taking advantage of manual labor who has to do all this backbreaking work to be able to create this. But, each one of these things, it goes literally from the coconut. The food products get directed in one manner, and the wood products come through another whole segment of the equipment. We also have here where we actually are breaking out the shell, and there's a fraction of the fibers also that gets turned into energy. We use a biomass gasification system that does a combined heat and power, which basically means that the way a gasification system works. Have you talked about it at all, TH?
Not enough, no.
Okay, so gasification system basically creates a combustion reaction in a low oxygen environment. Basically takes the oxygen out of the system, and what happens is you have a very high burn rate, but it generates this syngas, which basically you have a byproduct is some biochar that comes out on one side, and you have a synthetic gas that actually comes out the other side that's actually then used to fuel a generator. So what happens is the heat that's very hot, I mean, maybe 500, 600 degrees centigrade, that's actually doing the initial combustion. We actually now use that because to create this wood, the reason why people don't do it is because it's very energy intensive. It takes a lot of energy to be able to, both electrical power and heat energy to be able to make that wood that you saw here. It's literally an exorbitant amount of heat and pressure, and unlike other wood that's when they use glue, they can use a lower temperature and lower pressure. But in order to do this, you need the high temperatures and the high energy input. The reason why it's never been feasible is because there's not been an energy source. What we did is we're actually taking a fraction of the coconut product, which generates its own energy now, and we now have the heat that makes the heat portion, and we also have the electricity which powers the rest of the plant, which is why we're 100% off grid. There's probably about on this, it's one of the lowest emissions factors. I think it's about 2%, and that's before we actually put scrubbers on there. So Robert's got a system of actually scrubbing it, so we'll have 0 emissions out of this at all. There'll be nothing, no greenhouse gases that come out, and the only other byproduct is biochar, which is a soil amendment that we use for the regenerative farming.
So elegant, and just for reinforcement, if you don't know about gasification, the idea of doing combustion without oxygen, so anaerobic combustion, means that it can't at that point, because it has no O molecule, produce carbon dioxide. The carbon just has to sit there as carbon. The hydrogen comes off, so you have a carbohydrate basically, a hydrocarbon that's got oxygen a little bit in it if you're talking about the plant material. So just look at the chemistry that you learned in high school or wherever. If you take that and there's no O molecule to bind or O2 molecule to bind, you're going to get carbon black and you're going to get hydrogen. sometimes with a little carbon monoxide, because it has a little oxygen in that process, right, because it's a carbohydrate, oxygen. So you will get syngas, which is really CO plus hydrogen. And that is a hydrocarbon gas. Leakey, the guy who discovered the oldest few hominids, he told me at National Geographic he used to drive his car all around Tanzania and Kenya by going and gathering deadwood from the side of the road and putting it in a gasifier on the back of his Jeep. It then created a syngas, and he would drive his car on that syngas, and then he'd come home and he'd take the biochar and he'd put it into the garden. So it's been known for hundreds, actually, of years.
Yes. In fact, I think in World War II, the US government had put out pamphlets that helped people because they thought they would have fuel shortages, of how people could use these, make a backyard gasification system and power their farm equipment, for example. I don't think they ever needed to do that, but it was, you Google it and, there's these old documents that were put out by the US Army Corps of Engineers about how to build backyard gasifiers for that. So, yeah, it's not like a new technology, you just don't see it used very often. And again, that is a critical piece to what enables all of this to work. So again, a lot of times we have companies that will look and go, oh, well, we know that again, if you're making it just that coconut, there's a lot of smart people who know how to make things. I mean, people making wood for, a long time, they make engineered wood products. But what makes our thing unique is, again, this entire system that enables us to have the raw materials without having any, all these zip lines are electric. They're generating the electricity from the plant itself. So there's no carbon emissions that are coming from transportation. Normally when you're carrying raw materials in, it's trucks, it's diesel trucks, or some other mechanism of conveying all that raw material that needs to go into the factory. We don't have any emissions from that. And so when you look at our, part of one of the things you need for a sustainability project, the LCA, the life cycle analysis that you do on a project like this, there are no emissions that come from any of our logistics of moving the material off. The only logistics that we have now are the cost of, once we have the finished product, getting it back off the island, but we're already working on, can we use some other fuel source to be able to package up, to barge it to somewhere else where we actually can minimize, we won't need the diesel fuel to even get it off the island and into its final marketplace. And at some point, our downstream emissions, it's either scope 2 or scope 3 emissions would actually, again, there's not much we can do once we put it in a store, we give it someone's gonna get in their truck, so we can't control that, but what we can control, we're gonna make sure is this as little emissions as possible.
And I said that at some point we hope to have an exhibit at Rosebud of all the different components of this process. Russell, who you all work with on the new toilet that we're doing out of pallets, what we were talking with him the other day about doing with waste when you're cutting up the pallets, we're going to use a Sawzall for part of it, right? We're going to have some stuff that we can't use in construction. He'll put it in his gasifier, which you've never seen him offer, but he built a gasifier at Rosebud. It's sitting there. He used to make biochar, and he just needs an enthusiastic group of students and a reason to fire it back up again. He used to burn the syngas off. We go, ooh, while you're making the char, which he wants to make, is we're going to mix biodigestate with biochar because the crystallization of the wood has an enormous surface area. So when you infuse it with living, active biodigestate, which we hope to do with you out in the Philippines too, you get a superior biochar. It's not just, it's waiting already to be impregnated with the right microbes. Then you put in the biodigestate, and now you've got this great soil amendment. So Russell wants to do that, and then we're hoping that Robert came over one time and helped us repair the floor of our RV, which rotted out because we used OBS.
OSB.
And OBS is located in the studio, we use that for making videos, right? OSB, the OSB is that pressed lumber that you see in many houses, and our floors are made out of it, and the RV industry uses it all the time. And a rat just gnawed into a tiny hole into a water pipe underneath the kitchen, and it dripped for a year and saturated that OSB until finally the floor was collapsing. We didn't know, because so OSB is terrible. Now, Robert replaced it with some old timber from a house that I guess was his old house, right. And it's still holding up, but it was a used timber. He's going to come back, he said, at some point and try to do the floor in this so we can show people this is the best thing. OSB has no place in this world with its toxic glues that are off-gassing for your children and stuff. And so we hope that Rosebud will be a place where as more and more people come, like Nat Geo's coming, by the way, I want to invite you up, April 2nd through 6th.
Yeah, let me know, please send me a note on that.
Yeah, talk about that. And then, and have these showcases, and then say, this is when you're able to deliver, its content without the IP issue.
Right.
When you're ready, like, this is how it's done, and gasification here, and, photoelectric here, and every component, so people can see, this is the ultimate permaculture project.
Right.
I know you're salivating about that. Here's what.
Ruling over here.
Here's the-
But this again goes to the opportunity that you have here with, you know, with this guy here, because again, it's like the connections that he has to do this. You have the ability, you have someone who wants to help you with gasification. That is a key, that's a key project to a key piece to ours, and it's a key to a lot of things. And then combining with the biodigesters, I mean, you have the experts to be able to demonstrate and to work with that on here. So again, just kind of going through this real quick, and we'll just hit this quickly. We actually expanded, that's all 17 now. And we did that because we were able to get the government, which is always the hardest one. This is one of the schools.
Was that what 17 is governance, and
Yes,
that's what?
no, it's ability to bring people together from different governments and different countries. So it's basically unification of all of global communities.
It's rare when you have a project that hits all 17 areas.
Yes. Yep. So again, focus on the people. This is one of the schools that we helped down there. We donated a bunch of school books there. And again, we're talking about removing, and we're not gonna remove 10, it's 5. That's my son, actually, he's one of our ambassadors. But again, we're showing holding wood instead of, you know, you look at the plastic. He's half Filipino, by the way. And that'll be still on target for summer 2023, which is coming up. This is actually the plantation itself. This is not Unreal Engine. That'd be very good if it was Unreal Engine. That's actually a real plantation itself. You can see it's coconut trees as far as the eye can see. This is a plantation lot. Again, it literally is just one tier. But you would see here in the plantations that we're building, they're actually 3 tiers. So you'd see the, you know, a middle tier and then a, you know, a ground level tier on there as well.
You're saying cacao and?
Cacao, coffee, and mango would be the 3 crops that we have depending on the area of the Philippines, because they each have little microclimates that are better suited and soil that's better suited for different crops on there.
And what was Mike Tintner growing? He's got coconut as the top tier, and then he had
Mango papaya.
jackfruit. How did that meeting go, by the way?
Oh, went great, yes. Yeah, went great. We definitely got a lot more stuff that we're gonna be talking about. I need to get down and see his place for sure though. 'Cause that's like, there's not too many people growing coconuts here in Florida.
I thought that was a match made in heaven, if it works out, the personalities mesh. He really impressed me when he was down at Andy Firk's Bamboo Road, and then when he came and talked to the class, and we felt a lot of synergy. Also, he's a documentary filmmaker as well, and he produced, as we told you, he produced a film on indigenous wisdom. He's gotten very close to the Seminole groups.
Wow.
And spent a lot of time with the Seminoles, and so the indigenous knowledge component is very strong.
Right. Yeah, we have a lot on board with him. The reason why Robert wasn't able to be here, we're actually on a kind of a technology term. We're on a development sprint right now, trying to get. We have another product we haven't announced yet, which I'll share with you guys. Don't go publishing this just yet.
I'm gonna take the camera off then.
But we had developed a new, you see most of the wood that you'd be building with technology